Everything you see on your screen right now is powered by classical bits, a unit of information that can only be 0 or 1. But qubits, otherwise known as quantum bits, are different. They can be both 0 and 1 at the same time, a property known as superposition. Qubits can also be entangled, acting as one system even when separated. These features allow quantum computers to process information in much larger quantities and much faster than classical machines, giving them much more power. But here's a problem with qubits. They're extremely fragile. The tiniest disturbance, like a bit of heat or a stray magnetic field, will cause them to collapse, losing both their previous information they had stored and their special properties. It's called decoherence. Imagine trying to keep a soap bubble intact during a storm. Yeah, that's pretty hard to do. Scientists have tried building shields and clever error correcting methods, but qubits being this fragile is still the biggest roadblock to practical quantum computers. But recently, scientists found a way to stabilize qubits using magnetism. They stack magnetic atoms in just the right way so that electron spins don't all line up, but twist into repeating vortex-like pattern. And that's exactly what you're seeing here. This vortex-like pattern is called quantum spin texture. The black dots represent magnetic atoms. These blue arrows represent the spin orientation of the atom's local electrons. The red dots represent electrons moving through the quantum material. Since these electrons are in the interior, they are very vulnerable to scattering and decoherence. This textured magnetic background gives rise to topological edge states, which are special electron pathways that only exist around the material's border. In these topological edge channels, electrons don't normally scatter the way they would. Instead, they move in tightly guided protected paths. Because these edge states are resistant to the disturbances that normally cause decoherence, they allow qubits to preserve their information far longer. Scientists are still doing research about topological qubits, but these discoveries could help overcome some of the biggest roadblocks in quantum computing.